So, Jason, what are we talking about today?
Tim, I got a fun one for you.
Okay.
I've been banging on about entropy for a long, long time in this podcast. You and I have a fun time. I hear it in your voice. You love it.
I love it.
You know what? I was asked a question very recently by a journalist.
Okay.
Very thoughtful question. One of the bugbears you and I have, Tim, is the connection between quantum cryptography, quantum random number generation,
Quantum key distribution.
Our favorite bugbear. And there's another one.
Quantum anything. Just
Quantum
throw the word
anything.
Quantum in the front. Yes.
So, but the question was actually really good. And the question was, Jay, your name is connected with the topic of PQC and quantum. And I want to ask you about quantum clocks. And
Right. Sure.
all right, let's talk about quantum clocks. And so I had to think fast, right?
Right.
All right.
Sure.
I had to think fast. And so I said to myself, I got it.
Okay.
The connection between quantum clocks and cryptography is absolutely through quantum. It is absolutely through the concept of entropy. It is absolutely through the concept of using quantum random number generation. So here is part of what I said. I just want to share this on the podcast. Quantum random number generation, as we've heard before, is one of the reasons why it's interesting, not directly related to quantum cryptography. By the way, people, if you didn't know, you don't need a quantum computer to utilize quantum resistant cryptographic algorithms. Don't need a quantum computer at all. Okay.
Correct.
This is in defense of a quantum computer. It's not using a quantum computer.
Right.
So if we're talking about a quantum random number generation system, yes, you are talking about a quantum field. You're talking about sending a laser into, basically this concept of being able to have absolutely no way to predict which way a photon's going to go.
Truly random. 100% random.
It's so random. I don't even know if we've ever figured out another system in the universe that is more random, which makes it so great.
Yeah.
So it is exploiting the creation, like the term entropy by Claude Shannon, which the original term of entropy in physics is about energy loss. The term energy, the concept of energy loss in the universe, the word entropy was used. Claude Shannon took that great idea and said, never mind energy loss, how about information ambiguity? And in other words, if you cannot predict which way a photon's going, that means you have absolute maximum entropy in that sense. You have a very high entropy.
Yes.
So it's the unpredictability of the next thing. And definition of randomness, right? So therefore, what's a quantum clock? A quantum clock is actually doing the absolute opposite from an entropy standpoint. It's the absolute reduction of entropy. In other words, if you shine a laser into a particular point in this quantum field, it will actually create almost like a ladder, a laddering effect of the light. And the distance between, or if you want to count the clicks, if you were to move across this ladder, are so precisely identically the same, you can use it as a clock. And this absolute precise coming together of the same information is the completely reduction of entropy. So it's the opposite.
Is a quantum clock, is this an accuracy thing?
Yeah, it is.
Is that what it's about?
It's so accurate, Tim.
Possible clock.
The reason I think it's coming into the news, and you and I talked, Tim, offline about, hey, we should do a GPS hacking episode because that stuff's going on right now, right?
Yes.
Well, think about if GPS clocks are not giving you precise time, you might need something else. Maybe a quantum clock's a good idea, which I think it's getting in the news right now. So that's one topic. The other topic, though, is super incredibly interesting is, Tim, with a quantum clock that's so accurate, never mind even like an atomic clock, we're talking quantum clock. which might be, twice to an order of magnitude more accurate, depending on what you're actually measuring. You can now start to measure dilations of space-time in different places.
Nice.
So not only is it, say, a wartime, you can see why the military might use it, but you can also see why scientists would be incredibly interested.
Absolutely. So you're saying I take the quantum clock and I put it in something very fast, and I can actually measure the different time passage in normal speeds that I can achieve with normal equipment.
Stick it in a satellite, send it into space, see how time and space bends with gravity. Incredible, right?
Yeah, very cool. Super cool.
Anyway,
All right.
that's a quick one for you, Tim.
There you go. Quantum clocks. What's next? Quantum bladders, quantum lunch, quantum house pets.
Quantum lunch sounds good. I could use some quantum lunch right now.
Absolutely. All right. Thank you, Jason.
Bye-bye, Tim.